All right, this is lesson 5.1. It's all about percent increase and decrease. How to use percents to describe change. So finding the percent increase. Percents can be used to describe how an amount changes. And this is an important formula right here. The percent change is the amount of change divided by the original amount. And the change can be an increase or a decrease. The percent increase describes how much a quantity increases in comparison to the original amount. So in our example, we use this. Amber got a raise, and her hourly wage increased from $8 to $9.50. What is the percent increase? So, as it says here, it's a comparison to the original amount. So we have to compare it to the original amount. How much did it increase by? Well, we'll take that greater value, which was $9.50, subtract $8, our lesser value, and we get $1.50. So it changed by $1.50. But in comparison to the original amount, how much did it change by? That's where we get our percent change. So that amount that it changed by, and we can also reference this original amount. So the amount of change divided by the original amount. So the amount of change, $1.50, divided by the original amount, $8. When you throw that into a calculator, which I'll do here, we get what? $1.5 divided by 8.1875, which we would know is 0.1875 is equal to 18.75%, because we moved the decimal 2 times to the right when turning a decimal to a percent. And this 7 turns the 8 into a 9 because 7 is 5 or more. So that's why it's 19%. What does 100% increase mean? Well, it means that you've changed it by the equal amount to the original amount. So here, 100% change would mean we've increased it a full $8, not just $1.50. That would be 100% change. So it also could mean that the amount doubles. So if we start at $8, we increase it by 100%. That's another $8. We've gone down to $16, which is double the size of 8. All right. So what we have is your turn question. The price of a pair of shoes increases from $52 to $64. What is the percent increase to the nearest percent? Well, what I did is I used this same formula here, the amount of change divided by the original amount. The amount of change is the larger number minus the smaller number, which is 12. The original amount was $52. The original amount is the first number that's given. And when I divide this out, I get 0.23, which is equal to 23%. So we have next page here. Now we're doing percent decrease right here. When the change in the amount decreases, you do the same kind of thing, but it's called a percent decrease instead of increase. And in this case, David moved from a house that is 89 miles away from his workplace to a house that is 51 miles away. So there's a decrease from 89 to 51. What is the percent decrease in the distance from his home to his workplace? So once again, we have to find the difference between the two values, the greater one minus the smaller one. So there's 89 minus 51. That difference is 38. And we use that same percent change formula. That amount of change, which was 38, divided by our original amount, which was given as 89 miles, or just 89. The original amount is always the first number that's given. And when you divide them out, in a calculator, you get 0.427, which 0.427, if I move the decimal 2 times to the right, that is equal to 42.7%. This rounds that to a 43 because that's 5 or more, and there you go. Okay, so David considered moving even closer to his workplace. He claims that if he had done so, the percent decrease would have been more than 100%. Is David correct? Well, I'm saying no. The least distance that David could live from his workplace is 0 miles, which is a 100% decrease. And Well, any decrease that's more than that is impossible. So, you would have to decrease by 100%. So he was, what, he's now 51 miles. He would have to go to, so it would be looking like this. He would have, I'll put it over here, 51 miles originally, and then he decreases so he could live, that he can go down to the full 51. So he now lives at his workplace. And then that 0 divided by the original amount is 0% right there. You can't go beyond a 0% as far as decreasing goes. Increasing, oh yeah, you can go way above 100% on increasing, but not decreasing. Okay. So in these your turn questions, the number of students in a chess club decreased from 18 to 12. What is a percent decrease? Well, I subtract the two numbers and divide by the original number. When I subtract them, I get 6. The original number is 18. And I saw that this simplifies to 1/3. And I know that 1/3 is 33% as a decimal. It's actually 33.3 repeating, but I just, round to the nearest percent right here. If I have 16, it's 6 divided by 18. 6 divided by 18. If I do that, I get this, which is 33.3 repeating. But it says here, round to the nearest percent, which means the nearest whole number. We have 33.3 repeating, that's 3, 3, 3, and so on, percent, but we need to the nearest whole number. So we look at this number here, and that's 4 or less, so that stays the same at 33. Okay, Officer Primberry wrote 16 tickets for traffic violations last week, but only 10 this week. That is a decrease. So what's the percent decrease? Subtract them and divide by the original number. So that's 6 divided by 16. Throwing that in a calculator, you get 0.375. And they don't say to the nearest percent here because we're not dealing with a number that repeats here. This is called the terminating decimal, and that is equal to 37.5%. So this is repeating, and this terminates, or it comes to an end, but we call it terminating decimal. And now we're going to be using the percent change on the next page. Given an original amount and a percent increase or decrease, you can use the percent of change to find the new amount. Grizzly bear population in Yellowstone National Park in 1970 was about 270. Over the next 35 years, it increased by about 115%. What is the population in 2005? Well, find the amount of change. We know the percent of change. Let's apply that. So our original 270, and we have to multiply it by 115%. 115% is equal to 1.15. Because, you know what? I'll even go backwards for a moment. Why is that true? Because 115% means out of 100. And when you 115 divided by 100, well, when you divide by 100, you just move the decimal 2 times back, 1.15. So there's the 1.15 that came from 115% as a decimal. Multiplied out, that means the amount of the change was 311. So an increase by that, so we take our 270 that it was, and an increase by that, so that means we have to add it. We get 581 grizzly bears in 2005. So why will the percent change always be represented by a positive number? Well, in each case, the amount of changes has been the greater number minus the lesser value. And which greater minus lesser, the bigger number minus smaller number, that'll always be positive. Drawing conclusions, if an amount of $100 in a savings account increases by 10%, then 10% again, is that the same as increasing by 20%? No, it's not. This is growing on itself. So if you start with a 10% gain, well, 10% of 100, I'm multiplying that out, 10% of that, of means to multiply, is 10. So if I increase it by 10%, that's increasing it by $10. That's $110. Now, if I take that amount here, and I take 10% for the second year, 10% of 110, that's 11. You can multiply that out too. 110 times 0.10 will be 11. And so if I increase it by that $11, it's $121. That's 10% each time. That's called compounding. Compounding on itself, compound interest. But if you do just one 20% increase, that would be a balance of 120. So if I have $100 and I increase and I find what 20% of that is that's times 0.20, that would be $20. And if I have $100 plus that $20 for that one time 20% increase, that's $120. So it's $1 more if you do it 10% each time. Okay, so here we have a TV has an original price of $499. Find the new price after given the percent of change. Okay, $499, and I have to increase it by 10%. That means I have to find 10% of $499. And the word of means to multiply. So this is 10% is a decimal. 499 times 0.10, that's 49.9. Real easy because if you multiply by 0.10, you just move the decimal once to the left. And now I have to increase it by $49.90, which is a total of $548.90. 10% increase. Now, if I decrease it, that means, well, first off, if it's an increase, that answer needs to be greater than that number. It is. If it's decreased, that number needs to be smaller than that number, and it is. So I do this 30%. 499 times 0.30, that's 30% as a decimal, gets me, using a calculator, 149.7. Now, since it's a decrease, I have to subtract. 499 minus $149.70 is $349.30. So that 0.3 is the same thing as 0.30. There you go. I think that's all you got. Perfect.